set up a question like this using this first formula. Then there were 3 more formulas here, and I said I would show you what these things look like or how they even come about, and so I'm going to do that now. This is the only one that I'm not going to be able to show you yet because I'm going to prove that one to you graphically. But I can do these 2 right now relatively easily just in the space I have at the top of the page. So either just watch this happen to you, or you can write it down if it interests you. I am not going to require that you derive these things, but I do want to justify them for you. I don't want to just hand you a bunch of formulas and say, here, use these things. There is good, decent, proper physics and math behind all of them. So this last one is actually the one I'm going to jump to next because we need the derivation of this one to help us with this one.
Are you recording?
I am recording. I have just started recording. This one looks very, very similar to the D equals VT, except instead I've got a VI plus a VF over 2. And what this one actually allows us to, well, I'll show you where we're starting here. This one comes from the idea that a distance traveled is equal to your average velocity times how long you were traveling at that average velocity for. Yes? We're cool with this? This is the very first kinematic equation we talked about, talking about changing positions and velocity. This one, we were just calculating what your average velocity is. There was no discussion about whether or not you were speeding up or slowing down along that time. But what if I told you you were, in fact, speeding up and slowing down over the course of a length of time? How would you find the average velocity to then plug into this equation? Well, if I didn't tell you how you were accelerating, but all you needed was the average velocity, how do you find the average of 2 values? Add them and divide. If I wanted an average of a whole bunch of values, I'd add them all together, and then I'd divide by the number of values that I have. That is the definition of the average. So if I want to find the average velocity, and I just have my slowest speed and my fastest speed, well, my average velocity is just going to be my initial velocity plus my final velocity divided by 2. That's the definition, the statistical definition for an average. And if I multiply that by time, I'm going to get my displacement, which is this equation. So this equation is useful when you know you're accelerating, like your velocity is changing. You have an initial, you have a final, you don't know what's going on in between, but you know you're accelerating and you don't know how. That is where you would use an equation like this. I'll be honest, it's easily my least favorite, and I very rarely use it. When you do it as long as I do, you become emotionally attached to some of these things, and I don't like that equation. My favorite is actually the one I'm going to show you now. It's this monster here, and the derivation for this one is a little bit more involved, so let's do it. I'm going to go up above it here. I'm going to start here. So this one also starts with the idea that d, your displacement, is equal to your average velocity times your time. We've got a few pieces involved in this one. The 2 pieces I'm going to use are this definition right here for average velocity, and I'm going to use this definition over here for acceleration. So what we're going to get here is we're going to get d is going to be equal to v initial plus v final over 2. That came from here. Do I need to make a note of where that came from? I don't have to draw an arrow or anything? Okay, cool. The other thing I'm going to do is I want to bring in my acceleration term, and I want to get rid of time. So this equation is really useful when it doesn't matter how long you have been traveling for. You just know you've got an initial velocity, a final velocity, and acceleration. Or maybe you know your displacement in these 2 velocities, and you want to find out what your acceleration was. So I want to get rid of this time piece here in this expression. And to do that, what I'm going to do is I'm actually going to use this green expression here. I'm going to multiply time up, and I'm going to divide acceleration down. So I'm going to get time equals VF minus VI over A. Morning, Ahmad. And I'm going to plug that in here for T. So I'm going to get VF minus VI over A. Now, if I rearrange this thing a little bit here, I'm going to write it as my displacement is equal to V final plus V initial over 2 times V final minus V initial over a. If I look at the numerator there, that looks an awful lot like what? Something I guarantee you've seen before. Because I show my math 9s. Not reciprocals. Ignore that, ignore this. Just look at the numerators. That looks an awful lot like what? The result that you get when you factor a difference of squares. So if I multiply these two things back together, what I'm going to get is a difference of squares. So I'm going to get here, because multiplying fractions is easy, unless you're in my Math 9 class, you multiply the numerators, you multiply the denominators, and you're done. So this is going to give me d equals VF squared.
Second grade equation, I don't know the name of second.
A quadratic? It might be what you're looking for.
Yeah.
Yeah. It's just a particular kind of quadratic where you have two perfect squares being subtracted. We have a nice way of dealing with that. We call it a perfect, or a difference of squares. So I've got now VF squared minus VI squared over 2a. What I'm going to do now is I'm going to multiply by 2a, multiply by 2a. It's going to cancel on this side. And then I'm going to add VI squared to both sides. I know it's looking a little bit messy. But what we're going to end up with is VF squared. That's going to cancel. But then I've got VI squared plus 2AD, giving us this beast here. So all of these things just get derived from, they're not just magically transported here by your formula sheet. They all come from concepts that are relatively simple to discuss. Just some of the mathematical techniques get waved over. And the reason for that is no one should be barred from taking a Physics 11 course regardless of math skill. I've had students take my Physics 11 course with A&W Math 10 because that's almost all of the math skills that you need to get through this course, because I don't actually make you do stuff like this. I'll just show you stuff like this as we go. Physics 12 is an entirely different animal. So I'm going to do a couple examples, and then I want to give you guys some time to work through these questions of this type. You're going to get a handle on these things, I think, relatively quickly, assuming you buy into what I want you to do. So we're going to slide that up, leaving those equations up at the top. You don't have to memorize these things. You will, because you'll use them so often, but you don't have to, because all of them are actually in this first section here on kinematics. We've got speed, we've got velocity, we've got average velocity, we've got the one I don't like, we've got the first one we did, the one I'm going to prove to you graphically, and then my favorite one, all in this first kinematics section up top here. And everything that we do is going to be in this first chapter is going to come from these applications of these sets of equations. Now you've got them all. So there's a reason why I wanted you to set things up a particular way, and this is what I tutored. I told you last week, I tutored one kid for half an hour, and it was all he needed for the rest of Physics 12. Not because he didn't understand the physics, but because he had no tools to actually approach these things. So what is the displacement of a train as it is accelerated uniformly from 12 meters per second to 40 meters per second in a 25-second interval? So again, just like before, same techniques I apply. I want you to write down what you know. Just categorize it nicely somewhere. I don't particularly care where. I generally do it right here. But put it all together and pull it out of the question. So we know if we're going from 12 meters per second to 40 meters per second in a 25-second interval, what values have we just been given? Connor. Which velocity? Because we have a few. Now we're not talking about average velocity. We're talking about initials and finals.
You had an initial velocity of 12 meters per second and a final velocity of 40 meters per second. And I can't see.
You have, well, you have the paper in front of you too, but.
And then you have a time.
We have a time. We don't have an acceleration. We don't know how far he went. We're given these three pieces of information. But the beauty of these kinematic equations is all you need is three pieces of information, and you can find the fourth one, regardless of what I ask you to do. So in this particular question, what are they actually asking us to find? We want displacement. So which kinematic equation relates VI, VF, T, and D? VF, VI, T, and D. None of the other three do that. This one is VF, VI, A, and T. This one's D, VI, T, and A. This one's VF, VI, A, and D. So we have to use the one that I don't like. So we're going to have D equals VI plus VF over 2 times T. And now we're just going to fill the thing in. I've got 12 plus 40 over 2 times 25. So that's going to be 52 over 2, which is 26. 26 times 25 is 625, and 25 is 650. So it is as straightforward as it looks. The challenge that you guys are going to have, and I see it all the time, is being willing to actually go through the procedure. Pull out of the question, my grade 9s are doing it right now, pull out of the question what you know, and then find the right tool for the situation. In this case, we needed this guy here. Questions, comments, concerns? If I wanted to find the acceleration now, if this was a two-part question, I said, well, now find A. Here's part B. That's part A. Part B is find A. How would I do it? Connor.
Velocity final minus velocity initial divided by time.
Oh, so you're using this one up here? I've got a VF, I've got an A, or I've got a VF, a VI, and a T. So what you're using are the three that we were given here? Sure, we could do it that way. Acceleration equals VF, a change in our velocity, divided by how long it took to do that. So VF is 40 minus 12 over 25. So then my acceleration is going to be 40 minus 12 is 28. And that is not something I can do nicely in my head. What's 28 over 25? 1.12 meters per second squared. Is that the only way we could have found acceleration? We could have used either of the other ones too, because now all of a sudden we have D. And it's not only do we have D, it's a nice value we didn't have to round. 650 is just 650. It wasn't a bunch of decimals that we cut off. So we could use this result to go and find A2. I could have used this guy, D equals VIT plus half AT squared. I know T is 25, and I know D is 650 now. This one gets a little bit gross because it requires you to solve a quadratic formula. But we could have also used this one too, as Kieran already said. VF squared equals VI squared plus 2AD. I know VF, I know VI, I know D, and I can rearrange this one to solve for A. Relatively easy to use. Let's see another example. A car is starting from rest. It accelerates at 6.1 meters per second squared for 7 seconds. How far does the car move? What do I know? Final velocity is 6.1. Time is 7 seconds. Okay. What else do I know? The initial would be 0. Where'd you get that? The reason this example exists is not because it's abundantly different from the previous one, but because one tiny detail has changed. This sentence, or not this sentence, these two words right here imply something. What they imply is that your initial velocity is 0. You're starting from, oh, this should not be squared, because that's the final velocity. it's, what are we doing here? Oh, no, did someone, Connor, did you say that the final velocity was 6.1?
What? No,
Khalil, you said it was final was 6.1. And I just went with it.
seconds squared.
Accelerates at 6.1 meters per second squared. So we don't actually have VF. I just assumed, Khalil, that you were on it. That's acceleration, which you've already corrected yourself. Acceleration is 6.1 meters per second squared. And my initial velocity is VI equals 0. That from rest piece means initially I'm not moving. So now to find out how far the car goes, which kinematic equation am I going to use? This one? That would give me what? That would give me the final velocity. Is that what I'm being asked to find? So I could find my final velocity if we wanted to. That could be a decent part B here.
But by elimination, you can only use like the second and the last equation because you want to find the displacement.
I can't even use the last equation because I don't know what my VF is.
Yeah, so by elimination,
The only one I can use is which one?
the second one.
The second one. The one that I'll prove to you graphically later. The D equals VIT plus half AT squared. So let's use it. We'll in here again. D equals VIT plus 1/2 AT squared. And I want to find how far. So that's what I'm looking for. This is the only equation that relates what I'm given. So my initial velocity was 0. We like it when the initial velocity is 0 because this whole term goes away. Because I have a VI times a T. Well, if VI is 0, 0 times anything is 0. So then I want just the half times 6.1 times 7 squared. How far did the car travel in the 7 seconds it was accelerating? 149.45 what? Which one is it? You gave me 2. Why is it meters? Because it's well, displacement, but yeah, it's not a velocity. It's just a how far. Can someone verify this value? Because I did not plug it in. Manuel, you're getting did? Okay, cool. I could now go through and find VF, but now that I've got 1, 2, 3, 4 values. Oh, and was this exact here, Kiert, or did you round it? It was exact? Cool. Because it's exact and not rounded, we can use this if we wanted to, as an additional piece of information here to go find VF. But once you've got 4 pieces of information, any one of these equations can be used to find that last piece. So if I wanted to find VF, which one did we use last time? We used VF equals VI plus AT last time. Let's use this one, VF squared equals VI squared plus 2AD. My initial velocity is 0, which is great because that's just now gone. So I'm going to have 2 times my acceleration, 6.1 meters per second squared, times the 149.45 meters. And that's going to be equal to VF squared. So then my VF is what? 1,000? I assure you, you did not square. Because it's starting at rest. It's traveling 7 seconds at an acceleration of 6.1 meters per second squared. We could skip count that if we wanted to, but 42.7 makes a lot more sense. Because Manuel, just to put what you said into perspective before, and to think through your values actually makes a lot of sense. Over 7 seconds, this car traveled from rest to over 3 times the speed of sound in 6 seconds. I assure you the car disintegrated. Like, there's nothing left of the car. And so you got to look, that VF squared means to undo the square, I've got a square root. So you can analyze your values to see if they're reasonable. Cars going 3 times the speed of sound, not super reasonable. Spacecraft going 3 times the speed of sound, totally legit. We cool with what's happening here? Is this kind of making sense? Kind of the procedure? Okay, let's do a couple more. And then I will release you to work on these yourself. Okay, so an airplane must reach a velocity of 71 meters per second for takeoff. That is not universally true. That's just this particular aircraft. I don't know what it is, but this particular aircraft must reach a velocity of 71 meters per second for takeoff. If the runway is 1 kilometer long, what does the acceleration have to be for this aircraft? Connor.
You got a final velocity and you have displacement.
What's my final velocity?
71 meters per second.
What's my displacement?
The 1 kilometer.
The 1 kilometer. Okay. What else do I have? Typically, initial is 0. Yeah, for an aircraft for an aircraft taking off, often they start not moving. But notice how that nowhere is given to you in the question. You just have to pull that out of what you know of aircraft. So I'm hoping that we recognize that when aircraft take off, they start from rest. So there's an implied start from rest. And I remember back being in Physics 11 being like, what can I assume? Am I allowed to assume the thing's not moving? You're allowed to assume things that a reasonable person is allowed to assume. It's reasonable to assume that an aircraft is starting from rest. If you've never been in an aircraft, if you've never seen an aircraft take off, I can understand how that might be a challenge. But typically, I'm hoping by 16 or 17, at least you've seen an aircraft take off. If not, we're going to watch a YouTube video later of an aircraft taking off. So VI is equal to 0. What am I looking for? I'm looking for acceleration. Can I just launch into this thing? You sure, Connor? What's the problem, Tristan? My units are problematic. What's wrong with units, Tristan? They're not the same. I've got meters per second and kilometers. So the really easy unit conversion is to do what? Kilometers into, not in, well, I want to keep it a distance. Meters per second would be a velocity. I want to keep it into meters. 1 kilometer is how many meters? Kilo means what? Kilo means 1,000. If we ever forget, it's on the bottom of your formula sheet, has all of the prefixes we could use. Kilo, I've given it to you in scientific notation. 10 to the 3 is 10 times 10 is 100 times 10 is 1,000. So kilo is 1,000. So 1 kilometer is 1,000 meters. And now we can go. Which kinematic equation am I going to use? There are 4 of them, and only one of them relates to 3 things we know to find the one we don't. VF squared equals VI squared plus 2AD. So let's fill it in. VF is 71, and I'm going to square that thing. My VI is 0. We like that. That means this is gone. 2 times A times 1,000. And I want to solve this thing for A. So A is going to be equal to 71 squared over 2,000. Are we cool with how I did that? If at any point I shorten too many steps, feel free to say something. Don't be ashamed to be like, you did what? Hold on. And even if you, like, even just saying it, you see where the gap in your knowledge might be, that's totally cool. Manuel, we got. So then what's the acceleration here? Can someone verify? Sorry? You condone it? You're allowing her to suggest that? But does the number make sense? Do you agree with it?
Yes.
The words you use are important, Manuel. Condone means you're allowing her to say it. That doesn't mean that what she said is right or that you agree with the value. It just means you're allowing her to say it, which is big of you. As you know, she is your elder. I concur. The word you want is concur. Okay, last one. A car is, sorry, we're good? What I would be encouraging all of you to be doing is actually doing these calculations with us. Don't just let Gercuret and Manuel agree or disagree about these values. You should all have your calculators out with you doing these things because you're going to here in a second. Okay, the car is moving at 25 meters per second. It brakes with an acceleration of negative 1.5 meters per second squared. How far is it going to travel before it stops? So what do we know? Acceleration is negative. Thank you, Khalil. 1.5 meter per second squared. It's negative, and our other value that we're given here is positive, which means these things are acting in different directions. So if I have a velocity and then I have a positive velocity and a negative acceleration, we looked at it before, a positive velocity with a negative acceleration, that means I'm still continuing to travel in a positive direction, but I'm slowing down, which makes sense given the context of the question. What else do we know? Sorry? Do I know displacement? I want to find the displacement. That's how far is I'm being asked to find displacement. An analysis of units is really quite important. A per second anything is the rate of change of something. Rate of change of displacement is a velocity. Rate of change of velocity is acceleration. So as soon as you see a per second or a per second squared, it can't be displacement. So this is then what? That's my VI. Connor, is that what you're going to say too? That's my VI.
Yeah, the VF is 0 because the car stops.
It stops. It is reasonable to assume that a stopped vehicle is not moving. 0 meters per second. Okay, which of the equations are we going to use to solve this thing? The last one. My favorite. No, the last one? Last one's the one I hate, I think. The last one is VI plus VF over 2 times T. Do I have a T?
No, you don't have a D, so
I don't have T. I've got VI, VF, D, and A. Third one, my favorite one. The reason it's my favorite is because it's easily the most useful. Until we do projectile motion, and then the one that I have to prove to you graphically is actually the most useful. So this is the one that we're going to use here. VF squared equals VI squared plus 2AD. Because this is the information, and this is why it's so important for you to catalog what you've got. You put it right in front of you. You don't have to carry things around inside your head. The more you carry in your head, the more fatigued you get mentally, the more prone you are to making simple mistakes. So VF squared equals VI squared plus 280. Let's fill it in. VF is 0. Now, previously, when I had a 0 value here, I just had an arrow through it, crossed it out, put a 0, and then it never showed up again. Can I do that this time? No, because it's the only thing on that side of the equation. So I have to actually put my value, that 0, in there. So because I'm going to get 0 equals, VI is 25, so I'm going to square 25 plus 2. Now, I have to actually, the reason we talk about negatives and positives, we actually have to put those in there when they're attached to the values that were given. If my acceleration is negative 1.5, I have to put it in there as a negative 1.5. And I'm looking for a displacement. So we'll simplify some of these things for you. 25 squared is 625. So I'm going to get 0 equals 625 minus 3D. Because 2 times negative 1.5 is 3. And instead of adding a negative, I'm just going to subtract. That's what's happening here. So I'll add 0 equals 625 minus 3D. Do we care what my next step is? Some people do. My grade 9s would. You want me to add 3D to both sides? That is what my grade 9s would say. They would say add 3D to both sides because what does that do? Their big deal is that it would ensure that nothing is negative. Because if I subtracted the 625 over, I'd have negative 625 equals negative 3D, and my grade 9s see a bunch of negatives, and they start to sweat blood because they don't like negatives.
The negative is not the biggest problem because if you, like for example, found negative g, you just like multiply it by -1, and that's it.
Well, the issue comes, so I've got 3D equals 625. This is the route you suggested, Luis, and you're right. Let's just finish it off. Divide by 3, divide by 3. Here it cancels, and I get D equals, what's 625 over 3? 208.3 repeating. Okay. What I sometimes see here, when students opt to go this way, they're like, I'm going to leave the variable where it is, I'm just going to move this thing over. They subtract the 625, and then they drop this negative. They'll get negative 625 equals 3D. Because they'll say, well, I'm not subtracting anything, so why do I have that? Get rid of the subtraction sign. Is what I see happen all the time in math. And that's not what's happening here. This is, you can think of it as subtraction, or you can think of it as the addition of a negative. You need to be able to jump back and forth there quickly. So if I subtract 625 over, I'm left with negative 3D on the right-hand side because technically speaking, it's minus 625. Well, 625 minus 625 is 0, and 0 minus 3D is negative 3D. So that negative has to come along, and that's the one that I often see dropped. So now I would divide by negative 3, I divide by negative 3. Here the negatives would cancel, leaving me with D, and a negative over a negative is a positive. So I'm just left with 625 over 3, which is the value I calculated before. You just got to be careful when you're dragging around minus signs, because those are prone to disappear. If my displacement was negative, would that make sense? Why would that not make sense, Connor?
Well, if you're slowing down, you can't take back distance, you're still going forward.
Correct. A negative displacement means somewhere along the line I started going backwards. And I didn't. I dropped from 25 meters per second forward to 0. Nowhere in there did I turn around and start taking off the other direction. So this value needs to be positive. And there it is. Cool? Comments, questions, concerns? Hearing nothing, flip the page. Here's the questions I want you to do. There are way more here that well, not way more. There are more here that I'm going to assign. I want you to do 1. I want you to do 3. I want you to do 5. Ooh, I want you to do 4. 1, 3, 4, 5. want you to do 6. I want you to do 8. Ooh, I want you to do 9. So I just took off 2 there. 2 and 7 I dropped off.
You put that in Google Classroom.
And then I want you to flip the page. You've got the handout right in front of you there, Connor. You don't?
You said you were gonna put it online.
Yeah, well, then I didn't.
Weekend.
I didn't. I forgot.
That's fine.
There's a few of these I definitely want you to do. I like 4. I like you can do all of them, but I'm circling the ones I definitely want you to do. Oh yeah, we're definitely doing the bonus and the super bonus. Those are definitely happening because they're great questions. I want you to try those. So 4 bonus, super bonus, and which other one did I give you here? I don't want to do too much overlap. 9 is the same as 3. Do I have a final rate of acceleration question in here? Can accelerate. What is the acceleration? Let's do number 1. How long does it take to stop if a child if for coming to rest? That's it. 1, 4 bonus and super bonus off this page, plus the ones I assigned off. And you got 25 minutes now, lots of time to play with these things. If I'm not, I mean, again, this is not meant to be a challenge. Get your lined paper out, Manuel, and do these questions not on this page. Not a challenge, just a formal request. On your mark, get set, giver, Manuel. Yes, you have. Or was it Connor? Maybe it was Connor. Oh, I'm sorry, Manuel. Connor.
That was my program.